All right, Algebra 2, moving on to Lesson 3.2. We're talking about graphing, and we are talking about linear equations. Graphs of linear equations in two variables. Our essential question is, can you graph linear equations? We're going to learn a few ways of graphing. Before we do that, we're going to talk about some definitions here. The first one is the coordinate plane. Remember that this is the x-axis of the coordinate plane, and this is the y-axis of the coordinate plane. Axes are just when we talk about it together, we have it y and x axes. The origin, most of you know the origin is right here, and that is at 0, 0. Quadrants. We have 4 quadrants, and they go around 1, 2, 3, and 4. We do write those in Roman numerals, so make sure that you're writing that the proper way. And the last thing we're going to talk about is coordinates, and we're going to graph a few right off the bat. Coordinates are in x, y. So let's review. This is the x-axis, and this is the y-axis, and all of our coordinates are shown in an xy way. So if I had to graph -1, I would start at 0. I'm going to do this in orange. And I would go -1, and then I would go down 3. Now this is the only graph we would actually show. I was showing you the dots to show you in which way to go. So that is -1, +3. If I had to go to 3, 3, I'm going to make very little dots. I would start at the origin, and I would go to the right 3 and up 3, and that is where the dot would go. So that is at 3, 3. 0, 4, 0, -4, we're going to start at 0. We're going to go down -4. 3, -3, again, start at the origin. Go to the right 3, down -3. And the last one is at 4, 0. And we're going to start at the origin, and we're going to go right 4, and we're going nowhere up and down. So just to review, the x's move left and right. The y's move up and down. We know this as standard form, ax plus by equals c, and this is the graph of every linear equation that we're going to talk about. Now, we've seen other forms. You guys are very familiar with y equals mx plus b. This is typically the form that you use. This is called the slope-intercept form. And there's another form we're going to be familiar with. It is called the point-slope form. Y minus y sub 1 is equal to m times x minus x sub 1, point slope form. Now, obviously, this one right here, the slope-intercept form, has a slope, and it actually has the y-intercept. In the point-slope form, guess what it has? A point and a slope. This form on the top right here is good for graphing a lot of times. So we are going to learn how to graph working with the standard form. So let's start off the bat. Notice we have x plus y equals 7. I'm actually going to run off the paper. Well, the standard form that we talked about would be this, ax plus by equals c. And this is really good to find the x and y intercepts. Now, I know that the x-intercept is when y is 0. So if y equals 0, what would x be? Good, x would be 7. So from here, I'm going to graph on the x, 1, 2, 3, 4, 5, 6. I actually ran off the page. Now, knowing that is the x-intercept, and the x-intercept is when y is 0. The y-intercept is going to be when x is 0. So 0 plus what is 7? Good, 7. So on the y, I'm going to go up 1, 2, 3, 4, 5, 6, 7, and I'm actually right at my equation. From here, I can draw a line that's connecting these. And notice I don't have to solve anything. So if we go back to that standard form, ax plus by equals c, that is good in finding the x and y intercepts. So can I do the same here? Yes, I could, on example 3, graph by solving for y, and I'm going to show you that one as well. But in this case, let's go ahead and use the x and y intercepts. I know that the x-intercept is when y is 0. The x-intercept is when y is 0. Well, this is just saying 0 minus 2 times what equals 6. And in your head, you probably know that that's negative 3. I also know that the y-intercept is when x equals 0. Y minus 2 times 0 equals 6. So y equals 6. So that graph is 0, 6. So let's graph. The x-intercept is at negative 3. We're starting at the origin. We're going backwards 3, or to the left 3. The y-intercept is 0, 6. So I'm going to start at the origin, and I'm going to go up 1, 2, 3, 4, 5, 6. And notice I have a line like this. Many of you would prefer to solve for y, which is not a bad thing, but I just want to show you how easy it is if you're, fighting for time to go ahead and put it in the x and y intercept. Now, let's go ahead and solve this for y. Let's say I just solved this for y. If I solve for y, I'm adding that 2x over. So remember, you can graph this. The 6 is the y-intercept, so I would just put my dot there. And the number before the x, the m, is the slope. This is y equals mx plus b. B is the y-intercept. M is the slope. 2, we're going to be 2 over 1. So if I go up 2 and over 1, that's still going to be on the graph right here. But I can also go down 2 to the left 1, down 2 to the left 1, down 2 to the left 1. Notice it's the exact same thing. So you guys can choose. A lot of you just like to remember y equals mx plus b, and that is fine. Notice this one is starred. A lot of you forget where y equals 2 is. Many of you would just graph that. Sorry, this is y equals negative 2. Many of you would just graph this here. But I like to teach my students HOI, VUX. HOI stands for a horizontal line. The slope is 0. I'm actually going to write that out for you. And this is when we have a y equation. So notice we have to actually draw a horizontal line here to graph my HOI. On the other hand, VUX. Notice this is an x equation. Well, this is at 1/2, so it's not just graphed like this. VUX stands for a vertical line. And the u is an undefined slope, and it is when we have an x equation. Notice there's no y in this equation, so I do have to draw a vertical line up and down like that. Notice HOI and VUX are starred. These are very, very common missed problems, so just make sure you understand what that means. Great job.